Now, the reason for proof of work in Bitcoin is that it is totally an anonymous blockchain. In other words, it doesn't have permissions. Anybody who wants to do mining can just get a miner, join the blockchain, and start mining. So it had to have a consensus method that could be totally anonymous at any time and be able to allow people to join it and not have to worry about violating the trust of other people, okay? When you have a permissioned blockchain, of course, you can choose who you let into the blockchain or who you don't, okay? So proof of work and proof of stake are the two most prominent methods out there for consensus for public blockchains. What you'll see in the other ones, they talk about delegated proof of stake or proof of importance. All of these others can be applied to private blockchains. Private meaning it's permissioned. For example, a blockchain will have people that will join it specifically to accomplish a certain task, like the DeFi or the distributed finance blockchains that are out there. There's a certain amount of validation of the person coming in before they start working in there to allow the blockchain then to have a much lighter weight consensus method. Proof of work is really a heavyweight consensus method. It creates a lot of work for the miners in order to accomplish the task and actually close each block. So what I want to do is go over what is actually happening in a block so you can kind of understand where it's going. A proof of work has various different components. Now, in every single block, you'll have the previous block hash, you'll have the Merkle tree root, you have a target, and then you have a timestamp, of course, when the block is finished, and then you have a version number, and you know what miner was on what software version, and then you have a thing called a nonce, and it is a number used once is the way the word nonce came about. So a number used once, in other words, it's a randomly generated number at the very beginning of the work that a miner does to close a block. Now, miners do two functions. They do, number one, they validate transactions that get included in the blocks. And the second thing they do is they solve this cryptographic puzzle. So what they do is they take the nonce here and they run the nonce through the 256 SHA hash, basically with brute force, keep running that nonce through this hashing. They increment it up once and then run it through the hash again and do it again and run it through the hash again. And what they're trying to do this whole time is to hit this target. Now, the target is a number that tells all the miners that they are supposed to hit a number that is below a certain value. So a nonce will have a certain number of zeros at the beginning of the nonce. And that nonce, the more zeros it has, the more complex or more difficult it is to solve to get that particular hash back out. So what happens is Bitcoin in particular wants to solve the hash or close a block every 10 minutes or so. When that block is getting closed too fast, they will increase the difficulty. In other words, they'll add zeros to the front end of the target and force all the miners to find a value that is much less, much smaller. For example, 1 is 1% of 100. It has two leading zeros if you think of it as a 3-character long string, 001. You have a 1% chance of solving for the target if the target is 001. If the difficulty is too high, say it's taking 10 to 15 to 20 minutes to solve, then you could decrease the difficulty by removing leading zeros. So maybe we can search for a 010 or 10, giving 10% chance of solving it. You could then see how long it takes to solve the target at this lower difficulty. This is the problem that proof of work is trying to solve. The target is 256 characters wide, so you can have a target that is with 128 zeros in the front of it. So you can increment the difficulty quite easily by adjusting the number of leading zeros. It could be 120 or 130 zeros at the beginning of the target the next time it is being solved. So that's really what proof of work does. And the computers that are the miners run this nonce through the SHA-256 repeatedly until they get the number below that. Once one miner accomplishes that, it's announced to the rest of the group. All the transactions then are put into that one block, and then the block is closed by that miner, and the miner gets the reward, and the next block is begotten. So what is proof of stake then? Well, proof of stake doesn't have any rewards at all. They have transaction fees. And each transaction fee then is rewarded to the miner that's willing. Well, they don't even call them miners, they call them forgers instead. Each of the transaction fees are given to the forgers in order to reward them for putting together the block and the work that they've done, so that there's computers being devoted to the proof of stake. Now, in order to get a stake, you have to stake your coins. In other words, you have to kind of lock your coins away and not spend them. You put them in a wallet that is visible to the blockchain, and this wallet is dedicated to your staked coins. So in the case of a blockchain like Solana, or Algorand is one good example, they will have a wallet. A person will have a wallet that will have a certain amount of Algorand in it. The wallet with the greater amount of Algorand in it will have a greater chance of being chosen as the one that gets the reward of those transaction fees and gets to close the block. So you show your commitment to solving the block and putting together the block by the number of coin that you're willing to set aside and stake for the privilege of closing a block. So you improve your chances by having more coin, which means you're kind of buying into it, so to speak. So instead of paying a lot of money in a proof of work scheme by providing miners that use up a lot of electricity and paying money that way, instead you lock your coin away for a time for the chance to close blocks and earn coin that way instead. So that's the difference. Proof of stake is a much more lightweight and faster method of moving transactions through, and that's one reason why Ethereum is moving to a proof of stake method next, so that it can speed up their network and hopefully lower transaction costs. Because right now both Bitcoin and Ethereum are overly expensive as far as putting together transactions, and the cost of those transactions is getting way too high. What really is happening is that the number of transactions that a particular network can put through is limited, and especially in the Ethereum blockchain, they've tracked, when the fees get higher, and what they've noticed is the fees get higher when the network gets more congested. People get frustrated and start spending more in order to get their transactions through. It really is a matter of fees get higher when it gets more congested, because the network just automatically suggests what fees it's going to take in order to get your transaction through. If you enjoyed the content that you saw today and would like to help me grow the channel, hover your mouse over my picture to the left and click on subscribe. There are also other videos showing on the screen that you might enjoy.